instructor in the other Capstone. Sorry?
I just started the recording, sorry.
Oh, okay. Yes, and I wish everyone very easy and enjoyable time today. Good luck.
Okay, thanks, Zoya. Eileen, you want to say hello?
Absolutely. My name is Eileen Urich, and I'm instructor in Harvard Extension School, teach several courses, and I look forward to hearing your presentations today.
Okay, thank you. Takayuki, you want to say hello?
Yeah, all right. Yeah, so I'm Takayuki Ida, a teaching fellow for Zoya Kinsler's a Capstone seminar in digital enterprise, and I always look forward to seeing a DJ students' presentations. They're always so diverse, so idiosyncratic, maybe even eccentric. And I've seen your papers a little bit, and I see that this semester is no exception, and I really want to hear about all of these projects. Thank you.
Thank you. Yes, we tend to have a lot more diverse group, which I think is very interesting. It's There's a marked difference between the two capstones. It's kind of fun to watch. Eric, do you want to say hi?
Sure. Hello, everyone. My name's Eric Giesecke. I'm an instructor at the Extension School. I teach software design and also software engineering in the spring. And I, like everyone, I'm very much looking forward to hearing the presentations tonight.
Okay, thanks. And finally, Peter.
Hi, Peter Henstock. I teach the software engineering capstone, and I looked at your papers, and I'm really looking forward to hearing your presentations.
Excellent. Love the background.
Thank you.
Okay. Well, with no further ado, let's get into this, and we'll see if we can satisfy Takayuki's curiosity about the idiosyncratic presentations and projects that we've all put together here. Bank Tank, are you guys ready to roll?
I think we are. Can you hear me okay?
Yeah, just fine. If you want to start sharing, I should have turned that on. So yeah, sharing is on. That should be ready to go. For reference, we'll go ahead and do the first two presentations, take a quick break. We'll come back for at least the second two, and then we can decide whether we want to take another break before the fifth one, just like 5 minutes. Also, I'm recording this, and I'm also going. I know a couple of people have asked about getting access to the recording, so I will save a copy of the recording. I'll put it up to the YouTube channel like I usually do for the final project recordings. And if anybody needs a copy of it, you can probably download it off of the Zoom page. If not, get back to me and I can get it for you. Now, here's some other people have clicked in, but let's go ahead and get things rolling. Bank Tank, it is all yours.
All right, thank you, DJ. And thank you all for being here, for your time and your attention. We are Bank Tank and have been asked by you, Sunny Bank, to design and launch an enterprise-wide information management solution. After closed-door planning sessions, we believe the following solution will enable Sunny Bank to compete with popular financial technology firms or fintechs and replace it on a revenue and customer growth track way into the future. Our objective and our intent is to make customers' lives easier so they can focus on family and other important parts of their lives and less on banking. Our wonderful team is made up of the following: Eileen Wang, Lucas Anderson, Rocco Mancini, Assad Mahmoud, and Andrew Amandare. Sunny Bank is a medium-sized infrastructure retail bank providing products and services to customers in the Western United States, mainly checking and savings accounts, credit cards, personal loans, and lines of credit and mortgages. Statistically speaking, it has 6.3 million customers, 270 billion in assets, and 2.3 products per customer ratio. It totals with 900 branches in total across the United States. In recent years, Sunny Bank has been challenged from the following current issues. The fintechs are eating away at profit margins, and customers are leaving Sunny Bank to pursue better products that fit their needs better. So what do we need to do as partners with Sunny Bank? We need to move and transform from a reactive banking model to a proactive banking model. Essentially, we need to change from waiting for customers to walk in to a branch or contact the bank to reaching out to customers to provide lending services and products they need when they need it. The objectives are clear. Sunny Bank has to increase customer loyalty, and the key to doing that is providing customers with better rates. They also have to improve the ability to match lending products to customer needs. And they can do that by learning from customer data to understand what they need and when they need it. And finally, Sunny Bank needs to improve social trust. And the way they do that is provide better lending services to unbanked customers and new customers. Our agreed upon strategy is simple and sequential. It's reflected in our architecture, our technology choices, and implementation plan. More on that later. And we need to implement a new information management processes and technologies that enable proactive sales downstream. We need to do this while being mindful to adhering to all regulatory and compliance needs as well. We also need to ingest and integrate our legacy data into high integrity environments that will preserve both historical and new records. And then finally, we need to capitalize on the data by gaining deep insights and taking proactive action with existing and future customers. And to speak a little more about our strategy moving forward, I'm going to pass the mic to Eileen. Eileen?
Thank you, Lucas. As Lucas mentioned, our goal is to turn Sunny Bank into a more proactive bank. Our proposed solution is that BankTank design and pilot the Sunny Bank's information management system. This includes not only the strategy regarding how to extract insight from our data and how to present them, but also architecture and tools that we ensure the system runs smoothly and is cost-effective. Among these, the key to proactive banking is how to understand our customer from the available data and provide what they might need. BankTank will integrate different types of data listed here. First-party data from Sunny Bank's legacy system. Second and third-party data bought from external vendors, which are anonymized. We generate valuable insight about customer behavior based on these data. This will enable Sunny Bank to identify potential opportunities and offer products and service to the customers, and eventually provide them with what they really need. Now, Saad, our partner in banking strategy, will talk about change paradigms.
Thanks, Eileen. As Eileen mentioned, Sunny Bank is looking to use data to transition from a reactive banking model to a proactive banking model for both new and existing customers. That entails that Sunny Bank anticipates the needs of the customers, which is not something that traditional banking currently allows. So if I were to communicate my own banking experience, I feel that every time I'm in a conversation with a bank representative, I'm just a credit card number to them, rather than a customer with multiple products. Our conversations are quite one-dimensional and transactional. And as a customer, I want a bank that treats me as a person and attends to all my financial needs simultaneously, rather than one product at a time. And so the elements listed on the slide that you're seeing are key descriptors to traditional banking. They demonstrate why the banks are reactive in nature and why they are not able to consolidate all the customer information to provide better service. And so Sunny Bank will look to transition from siloed product businesses to be more customer focused. And then currently it is the customers that initiate interactions. And so moving forward, Sunny Bank will be able to leverage its data to initiate interactions. It will also be able to transition from one size fits all lending to a more customized lending. And lastly, it will also move away from a minimal social awareness to a more improved social awareness. Now, Rocco, our subject matter expert in finance, will go over the business case.
So thank you, Saad. So for any organization that's undertaking a major project, one of the important metrics to look at is return on investment, or ROI. So in this situation, what we did was we looked at the overall costs. We aggregated the cost for the technology. We aggregated the costs for maintaining the technology over a period of time. And then we compared that to an increase in net income due to implementing the technology. When we compared those two numbers over a period of time, it generated an ROI of 20-to-1, which we felt was very favorable. So we recommended to Sunny Bank to implement and go forward with the project. We then looked at another metric. We wanted to be a little more granular. We looked at the branch level, and then we looked at how net income would be affected on a break-even basis. So all organizations want to recoup as much of their outlay as quickly as possible. So when we looked over this period of time, the implementation of project occurs over 2020 and 2021. The break-even point actually occurs in 2022. So at a relatively early period, mainly because the ROI is relatively high. So again, this project looked very good from a financial standpoint. Now to talk about the technology architecture is Andrew.
Thank you, Rocco. So the following diagram depicts our proposed high-level architecture. And reading from left to right, we have our data origins on the far left, feeding into our ingestion platform that prepares data for use in our looking ahead engine that generates insights for building targeted campaigns for our customers. On the far right, in blue, we have our dashboards used to track relevant metrics and our channel integration through which we will distribute our opportunities. The platform will also integrate with Sunnybank's existing data governance and IT operations tools. The next slide, the one that's on the screen right now, shows a superposition of the proposed products for the new platform. The most important element is our choice of the software as a service CRM provided by Salesforce, a market leader for CRM solutions. Other relevant players that we are going to be using in the platform are PowerCenter by Informatica to ingest and prepare the data, and Click to build some custom dashboards integrating with Salesforce through their native connectors. The front ends for the channels and customers will be custom built, pulling information from Salesforce through their APIs. Next, Lucas will provide further detail on the ingestion platform.
Thank you, Andrew. The ingestion platform was built around one question. How do we get uniform usable data into the looking ahead engine, our data management solution? And the answer comes with ETL. One, we connect Sunnybank's existing legacy databases and extract usable data into the transformation process using the Informatica tools. The second piece of the step, their sequence, we transform or wrangle that data and structure this data into predefined data schemas that we know to be efficient for queries downstream. And then finally, we load them into an enterprise data warehouse that can be accessed for downstream processing as well as many BI and other analytical needs. Now, that's how we ingest and feed the information in. And it's important to know that, but it's also equally important to know what we do not do with data. We do not ingest personally identifiable social media data or PII of any sort. External data, as stated before, is anonymized and all our process for ingesting that data abide by state and regulatory and business agreements with business partners. And to speak a little more about our looking ahead engine and processing logic behind it, I'm going to hand it over to Eileen again. Eileen?
Thank you, Lucas. So the looking ahead engine receives data from the ingestion platform and then generates sales campaigns for the sales advisors. The diagram here shows how the engine works. On the left-hand side, here are the data elements that are integrated in the ingestion platform. Note here, BankTank only use demographic data to recommend service and product. We'll never use them to make any loan decision. Then the data is fed into two types of algorithms. There is quantitative analysis, which is pure mathematical, that BankTank consultant utilize the power of machine learning to make unbiased predictions and discover potential opportunities that human may not be aware of. The other is qualitative analysis, which is developed with marketing and sales expertise based on the valuable human knowledge and experience about our customer behavior. To further improve the algorithms, here we have the performance analyzer that evaluates the effectiveness of the algorithms. That is based on ROI, customer attrition rate, and conversion rate. BankTank then adapts the strategies iteratively according to the evaluation. The results of the engine are presented by the data visualization tools that Saad is going to share its details with you.
Thanks, Eileen. So BankTank will be developing two data visualization tools, the executive dashboard and the sales team dashboard. These dashboards are intended for the executive, marketing, and sales management teams at Sunnybank. The dashboards are intuitive to use and will enable you to analyze metrics and trends at a glance and to make data-driven management decisions. And so if we look at the executive dashboard, we can see that there are three sections from left to right. The first is the conversion rates. The second is the total sales to looking ahead ratios. And third is the channel ratios. Each of these sections display a high level dial that shows us whether we are on target or not. And so as an example, if we were to look into the conversion rates at the next slide, we can look at the data at a regional level. On the left-hand side, we can select the state or the call center whose data we want to see. And then on the right-hand side, we can see the corresponding data being reflected, like the number of branches, sales alerts, etc. So this was the executive dashboard. Now to discuss the sales dashboard, here's Rocco.
So thank you, Saad. So our sales advisor, our customer service advocates, what will they have? They will actually have a customer profile. It's known as a sales advisor view. What it does is it integrates all the data coming out of the looking ahead engine and ultimately generates what we call customer alerts. So you'll see in the highlighted box, you'll see for this specific customer, two potential alerts come up. One is for the need for a potential car loan, and the second is to improve an unsecured loan rate. So what this ultimately does is it aggregates the information, and every time we reach out to a customer, we want to make sure that we're reaching out for the right reasons. We want to build customer value. The one thing we don't want to do is make the customer feel like we're reaching out to them for something they may never need. So if you flip to the next slide. So what the sales advisor sees, the customer will also see from an online banking viewpoint. So in this situation, what you see is a snapshot of the car loan potential. So depending on the amount of information we have, the looking ahead engine can output information that's very specific to this customer. For example, in this scenario, the customer can receive a loan up to $30,000 to buy a car. It offers a potential interest rate of 4.8%, a payback period of 5 years, and even a down payment. If we have enough additional data, it can also potentially offer makes and models of cars that fit what they may have been looking for or fit the pricing range that they're actually looking at. So in this scenario, you'll see 3 different types of cars that are offered. If we flip to the next slide. So for customers who are more used to using their smartphones rather than online banking, they'll also receive the same type of information in a mobile banking alert. You'll see it's a little more abridged, but ultimately it gives them all the same highlights of information, the amount for the potential loan, the APR, the payback period, etc. Customer also has at any point in time, they could proceed forward with this to get additional information. They can opt out of all this information. So we make sure that we want to only give customers things that they need. We don't want customers, again, to feel like they're receiving any type of spam or anything along that line. So I looked into my own personal situation and I said, you know, how has my banking relationships been? I have a major national bank for the past 15 years. I set up a checking account with them 15 years ago. I looked into the checking account and I said, okay, when I set it up, what were my costs? It was $10 a month. So I looked recently to see how much am I paying on a monthly fee, and right now it's $30 a month. Knowing that that's relatively high, I looked at this checking account and said, what are the services attached to it? I find out it's for unlimited check clearing. I haven't cleared a check probably in about 5 years. So what I probably should be in is a minimum balance, no fee checking account. But nobody's reached out to me, even offered me that. So I would have to be the one looking to see if that product's even offered with this bank. I then looked and said, you know, is this also something that might be happening on my credit cards? I have probably 10 plus credit cards, but I'm very diligent in making sure I have the lowest interest rates. I pay off balances, but I don't look at the fees as much. You know, most of the time when I open these up, I looked at one in particular. Of course, it was 0 fee when I opened it up. But then I noticed a few years later, they had moved the fee up to $20 per year. Then I noticed a couple years later, they changed it to $2 a month, which is not very far from $20 a year. But I looked very recently and I noticed it's now $5 a month. So what went from no fees now went to a fairly significant fee. And I look at these two interactions with what I would consider banking partners over the past 15 years. The only attempts they've done for anything is to really benefit them. I would personally want them to look at my current situation with any information I have and offer me any type of products that would fit my current needs that would be beneficial to me. Very similar to what Sunny Bank can do with their customers by implementing this technology platform. Now to talk about the actual implementation of the platform is Andrew.
Thank you, Rocco. So first of all, I'd like to briefly comment on our proposal for the project organizational structure depicted below. Its main traits are that decision-making is done by leadership roles in the bank at the top of the tribe diagram, led by the chief sales officer as the main sponsor. Execution, down below, is led by bank tank experts working in conjunction with both Sunnybank and bank tank professionals, shown in the squads. These traits will generate ownership and accountability in the bank's teams that will help break silos and drive to a successful execution of the project and continuing support going forward. Next, our proposed project plan starts with 6 months of design, development, and testing of the platform, shown here in orange, followed by 6 months piloting the platform, during which we will capture lessons learned and improvements and feed them back into the development process. And finally, 6 to 8 months completing the rollout in the rest of Sunnybank's footprint. We will pilot in Colorado, the home state for Sunnybank, and will roll out in 4 waves, leaving the largest for last, thus ensuring a more mature platform running in production. As we can see here, California is where we have the largest footprint, and we've got them down in wave 4. This approach is flexible and provides you with options based on your risk appetite. You can move states up and down depending on your appetite for going for more branches or not. The pilot and rollout phase will include change management and training for branch and call center staff, as well as customer engagement via campaigns to have them opt in for new product opportunity alerts. Next, we want to share the success metrics we believe are important for you to track as we implement the platform and track it over the years to come. We have concluded that success will take the following form. Increased customer loyalty that we will measure by our increased customer to product ratio that Lucas mentioned early on, and reducing our customer attrition rate, which currently is one of the problems that we picked up earlier on in the as-is. Bank growth that will be measured by an increase in our net yearly growth and increasing our sales to customers. Finally, we want to increase our social awareness, which we will measure through a reduction in customer complaints tracked through our bank systems and a measurable change in the trends in social media. It is also important we track our ROI, calculated at 20 to 1, that Rocco mentioned earlier during the business case. And finally, and to conclude, I just want to circle back to our objective and want to remind you that our mission is to help transform Sunnybank into a more successful and proactive financial institution for our customers, your customers. So let's flip the switch together. And now I open the floor to questions. Thank you.
Thanks very much, guys. I'm going to pause the recording while we do the Q&A, and we'll be doing that for between every group. Recording. Okay, so let me introduce a little bit of background on this next group, in keeping with our idiosyncratic and unusual nature in terms of projects for this course. This is a group that basically is deciding to do a proof of concept pilot program. So the committee should see itself right now as basically committee members for effectively a kind of an agency that disperses grant money to potential startups in this area. So rather than being executives, you guys are all looking to potentially give out some money to these guys to implement this idea on a prototype basis and test it out. And with that, I will turn it over to CAS to get started.
Great. Well, thank you, everyone. Thank you to the SARE program attendees for joining us today as we present Precision Farming as a Service. Without further ado, let's get started. Let me advance the slides here. Here we go. Okay, well, I'll first begin by framing the flow of our discussion today. We'll first start off with some quick introductory information. Then we'll present the business problem and how we see it as an opportunity our solution will address. Next, we'll dig into the solution itself. We'll dig into the technical architecture and our plans for the proof of concept, as DJ mentioned. Finally, we'll spend some time going over the financial information. Again, we want to start off by first acknowledging you, our guests from SARE. Again, thanks for attending this meeting. As for who we are Connected Agroecology Solutions, or CAS for short. We are a group of individuals with a shared passion of advocating for the effective use of data. Several of us have agricultural backgrounds. Our mission is to bring our passions and experiences together to help farmers reimagine their current practices in a way that makes them more productive, while at the same time reduces the impact to the environment. Our ask of you, SARE, is funding to support the build and test phases of the proof of concept implementation of the PFAS, or Precision Farming as a Service solution, at Brala Farms. The agricultural industry as a whole is facing many challenges. According to recent studies, demand for food is expected to increase significantly over the next 3 decades. At the same time, farmers are fighting against outside forces that are at odds with achieving increased yields, such as changing weather patterns that can negatively impact crop yields and may actually reduce the amount of tillable land. That challenge alone will make it difficult to meet the food demands of the future. Now, specific to US farming, the United States continues to be a major contributor to worldwide food production. We often think that industrial or commercial farms are more prevalent or most prevalent in the US, when actually family farms still overwhelmingly dominate in terms of the number of farms and acres farmed, as shown in the chart on the right. What's alarming is that the small family farmers manage almost half of the US acres farmed in the US, but only contribute about a quarter to US production, while larger farms are more efficient. One reason why larger farmers are able to do more with less is that they, generally speaking, have adopted technological advances, such as using technology to assist them with their growing decisions. The problem is that these technological advances are often out of reach for the smaller family farmer. If the small farmer is to play a role in meeting the demands of the future, they must start adopting similar innovations. The use of data in farming isn't new. Farmers have historically used all sorts of data. I grew up on our family farm, and my dad used the Farmer's Almanac. He used weather forecasts from the local newspaper or the morning radio show. As for what was happening on the ground, my dad measured precipitation from a single rain gauge attached to the clothesline in our backyard, which was miles away from some of our fields. To determine a fertilization plan for a particular stretch of land, we would gather soil samples from the various plots and take them in for analysis. What was provided back were recommendations on how much and what kinds of fertilizers we should be applying to the field. In both the rain gauge and the fertilization example, decisions were made using the law of averages. These practices do not take into account that there's variability in the land, that there's different soil types, that there may be wetland areas or ridges, the fact that it doesn't rain evenly across a given area. Now, larger farmers have adopted more modern techniques, but these traditional practices are still the norm for the vast majority of the small family farmer. To further illustrate these pitfalls, I want to walk you through an example of how an over-fertilization scenario can occur with a homogeneous rate application, which happens when treating a plot of land as if there were little or no variability. The picture on the left represents the soil nutrient levels for a particular field. As you can see, this field has nutrient levels covering the spectrum between low to excessive. Now, the blue overlay in the center depicts a homogeneous rate fertilization application based on soil samples taken from various locations in this field. A homogeneous rate approach means that you fertilize the field based on the averages of the soil samples taken. Now that's very different from a variable rate application where fertilization is customized to the specific nutrient needs of each section of that field. Now, on the right, you can see the result. The homogeneous rate application increases areas of over-fertilization in this particular example. Now, had this been a variable rate application, perhaps fed by precision data from the Precision Farming as a Service solution, which we'll be describing in detail shortly, we would know the near real-time needs of that field, thus reducing the chance of over-fertilization. Finally, I want to mention that studies have shown that more precise and near real-time measurements of soil needs can substantially increase yield, reduce water consumption, and minimize over-fertilization. Next, I'll turn it over to Frankie to introduce the PFAS solution.
Thank you, Ed. As Ed mentioned, the technological advances that lead to increased yield and reduced resources are often out of reach for the small family farmer. These solutions require specialized knowledge, infrastructure, devices, and analytic services. The small family farmers are often considered the jack of all trades. But this is one area we feel that they could use some help. This is why we developed Precision Farming as a Service, or PFAS, which will lower the barrier to entry for small family farmers. PFAS is a subscription-based model that masks the complexity of implementing and managing real-time soil and crop monitoring and analytics capability, providing farmers with the information they need to make the most informed decision to maximize yield. The PFAS solution is a bundled service that includes all the necessary hardware, infrastructure, both on premises or in the cloud, and analytical services. The base bundle, or what we call the starter kit, is sized by the number of acres that will be under monitor. This starter kit will be the minimum set of components needed and will provide add-on options and recommendation as needed. The picture to your right is a high-level overview of how the solution will work. In the later slides, we'll explain each component, including the drone, IoT devices, the cloud, and user interface on this picture in more detail. Let's talk about the expected benefit. Our solution provides direct benefits to small farms by addressing the following W questions faced by farmers. Determine how much water and fertilization is needed, identify what type of fertilizations to apply, isolate where to irrigate or fertilize, decide when to irrigate or fertilize, determine what to grow. The target of the POC is a 10% increase in crop yield and a reduction of 15% in fertilization usage and water consumptions, and hence an increase of the overall profitability of a farmer. If action is not taken now, there's a risk of losing small farms that produce specialized products, employ local farmers, provide locally fresh produce, support local economies, and progress environmental sustainability. Now I'd like to turn over to Jamie to discuss the architecture of our PFAS solution.
Thank you, Frankie, and thank you to the SARE committee for having us today. The PFAS system is made up of 5 key components: the drone, a network of soil sensor probes, an IoT edge device, cloud service, and the farmer's UI. The PFAS solution was designed from the ground up with built-in security using AES 256-bit encryption of data at rest, data in motion, and data in use. First, we're going to talk about the IoT soil sensor probe. PFAS relies on a network of IoT soil sensors placed strategically on a farm based on an initial drone scan and overlaid satellite imagery. These probes collect information on soil moisture, soil nutrient levels, and other relevant information. Our estimate is that on a 200-acre farm, we would need approximately 20 sensor probes to effectively cover the land while still providing accurate nutrient and moisture information to the farmer. This puts the distances between probes anywhere from 200 feet to 800 feet apart. This presented a problem when we were designing our probes. How do we keep the probes powered while also reliably connected to the network? To address this problem, we designed the sensor probe with a low power, low cost, long range technology for mesh IoT device connectivity. This technology can transfer data reliably at distances greater than 1 kilometer. We solved the power problem using a small solar cell and a lithium polymer battery that can power the probe for 40 days in low sunlight conditions. Our key component are our sensors. The nutrient sensors detect nitrates, potassium, sodium, and calcium levels in the soil. And the moisture sensor provides a 99% accuracy moisture reading. Now we're going to dive into the drone. In addition to the initial scan for probe placement, weekly aerial scans are conducted throughout the growing season to identify any changes in land gradients, crop coverage, crop color and crop height. This GPS-based data will be combined with the sensor probe data in an IoT edge device. Initial tests show that 200 acres of farmland can be aerially imaged every hour using the drone. Next, we're going to talk about the IoT edge device. The PFAS IoT edge device will be installed in the farmer's house or office or anywhere there's a broadband internet connection. The device is a lockdown PC with admin privileges for root that can't be used for personal use. The sensor interface with the IoT edge device receives data from the IoT probes placed in the fields and aerial footage from the drone flight. The aerial footage and soil probe data is combined and used to build precision maps of the fields. This is also where the sensor placement is reevaluated and additional sensors can be added if needed. The recommendation engine takes the information from the IoT edge device information and builds out the specific actionable guidance to inform the farmer about potential problem areas, allowing them to take the corrective actions as needed. And that's where the cloud sync comes in. The cloud sync then passes along the data and summarizes it at the edge, that was summarized at the edge device up to the PFAS cloud service you see here. Aggregated data from the edge device will transfer to the cloud for decision-making capabilities. The data in the PFAS cloud will be combined with other data from relevant sources. The data then can be used and pre-configured for pre-configured precision farming equipment, such as spreaders, irrigation devices, and other such type equipment. Now I'm going to turn it over to Nav to talk about the UI and the PFAS proof of concept.
Thank you, Jeremy. So we know the importance of visualization, so we created easy to use dashboards and mobile application. Let's look at our dashboard. These are highly customizable according to the farmer's preference. The radio dial at the top shows the average moisture or nutrient levels across the farm, along with the critical third-party data such as rainfall or temperature, wind speed. And the heat maps in the middle, which shows the moisture and nutrient the map, are highly interactive. So the farmer can zoom in and see what is happening at the particular area within his or her farm. And the recommendations that were generated from our PFAS application will be shown in the recommendations section. The farmer can easily drag and drop to the reminders or to-do list to take any actions. Let's coming into our mobile application. Our mobile application runs on all the major mobile operating systems. The application includes the dashboards, recommendations, to-do list. But the most interesting and important feature of our mobile application is that when the farmer walks around his or her farm, we take the GPS data and shows the near real-time localized recommendations or information to the farmer so that he can see what's happening at this particular area within their field. And if the farmer sees any anomalies or something is not right, he can just take a picture or small video clip within the application itself to send it to the PFAS application for further analysis. If there is no internet or mobile connectivity at that particular time, we store the data locally, and once it's connected to the internet, we'll exchange with our PFAS application. And while the farmer is walking around the farm, he can easily take the notes or to-do list or reminders within the application itself. Let's look at our proof of concept. Our proof of concept runs about 7 months. In the initial 3 months, we'll spend our time to build our PFAS application. And the next 15 weeks, we'll test it at Brahma farms. Let's take a deep look at our build phase. For building of our IoT soil probe, we are sourcing to our vendor overseas to reduce the cost. And building of the IoT edge device and the drone here in the US. Our team of software engineers will develop the PFAS application and software interface, and they will test with the hardware components to make sure they're both working optimally. Additionally, we'll create a training material for both the farmer and the support engineer. Let's look at our test phase in detail. depending on the last freeze day of the year, we'll start our POC right around mid of April 2021. The initial couple of weeks, we'll work closely at the Brahma Farms to set up our application along with training Mr. Sri, the owner of the Brahma Farms, on how to interpret the documentation or dashboards along with the alerts and recommendations and act upon. Throughout the proof of concept or the test phase, our engagement manager and support engineer work closely with Brahma Farms on ground and give the notifications to appropriate parties. Throughout the growing season, we'll monitor the crop growth and send out the recommendations or alerts accordingly. After the harvest is completed, we'll evaluate our success metrics and take the feedback to see how the system is working or take any recommendations or improvements on the system. With that being said, I'm going to turn over to Jim to talk about the success metrics, financials, and wrap up today's presentation.
Hey, thanks, Nath. The success metrics for our POC have been defined as hardware availability at least 90% of the time, ease of use by the farmer measured by a questionnaire, 10% increase in crop yield, and 15% decrease in fertilizer and water utilization. The thresholds for crop yield and fertilizer usage have been set based on minimum efficiencies needed to support the PFAS subscription model during the early adopter phase, which is the next step to further refine the PFAS service based on the success of this POC. Water utilization efficiency is not used in the financial model given the immaterial savings. However, the improved efficiency speaks to sustainability achieved with the service and increased crop yield from not over or under watering crops. Now, to fund this success, let's take a look at the financial picture. CAS is requesting a grant of $195,000 to cover the build and test phases of the proof of concept. The components include hardware based on the PFAS starter kit, licensing of the cloud services analytics platform, one resource to manage the engagement with Brahma Farms, one field technician to implement and support the hardware on site, and 3 technical resources to build and support the cloud analytics and user interfaces. While the core success metric is a 10% increase in crop yield, research has shown that precision data-driven farming can increase crop yield by 45%. This gives the early adopter farmers confidence that the financial benefits will outweigh the cost of the PFAS service, as the PFAS service pricing is targeted to be no more than the revenue earned from the 10% crop yield improvement and the cost savings recognized from the 15% reduction in fertilization usage. This identifies a target $33,000 annual subscription cost for the early adopter farmers that have revenue of at least $300,000. The POC will help us substantiate this cost structure. We hope to put the $195,000 grant money to good use and realize the vision of closing the yield per acre gap between large and small farms with precision data-driven farming. I know we have covered a lot of material today, and you also have our 20-page proposal submitted for grant approval, which further details the business problem, solution, and implementation plan. If you have any questions, we're happy to address them now.
Okay.
I actually have a question. Yeah, thank you. This is an amazing presentation. I really enjoyed.
I need help with the sharing. Have you?
Oh, it should be turned on.
No.
Yeah, it's turned on. It's turned on.
Let me see.
Green button.
If I can see one.
Really?
Nope.
Uh-oh, that's not good. Wait a minute.
I see one.
Hang on. Let me make you co-host.
I see it now. No. It popped
Got
up.
it? Okay.
Yep. All good.
Just nerves. It's okay.
Of course. Can you see the screen?
Just starting to come up.
Let me know when it's fully up.
There we go.
Did the full presentation screen? Great.
Yes. Okay. All right. Prefacing this for the committee, these guys work for a Department of Natural Resources organization within the state, and they're embarking on a basically the second phase of a data governance and information process improvement project involving natural resources data. So they're not looking for money, they're looking for approval. Okay, take it away, guys.
Great. Well, thank you very much for joining us today. As you know, we are the IT services for the Environmental Control Agency of Minnesota. We are responsible for information management and IT services and support. Per your request, we have put together a proposal for your review in order to reduce the agency's time to analysis. As you know, the monitoring programs we have within the agency, the data for it is very crucial to funding appropriation, enforcement actions, and reporting on the Minnesota's overall health, environmental health. Our proposed solution will incorporate the recommendations and guidelines provided by the governance board of the agency to better align with agency objectives. Our team consists of myself, Joe, Denise, and Matt. And Joe will take us through the next step in identifying business problems as we have it. Joe, take it away, please.
Thank you, White. The business problem for Environmental Control Agency, ECA. Minnesota's ECA has a monitoring program division, and this has 3 business units. That is soil, air, and water, otherwise known as SAW. They conduct tests by going and visiting sites like a pond or a reservoir. ECA found that they had a problem, and this was that the problem was that when the reports that they got were coming out late and it was filled with errors. The time to analyze this data was taking way too long. That is, the time for a survey request from being scheduled to analysis is about 6 weeks. So the underlying issues behind it were that the scheduling was a manual process, data being collected was a manual process, there was manual data entry, the validation was another physically long and manual process, and there was lack of standardization in the data elements that was being ingested and also being exchanged. So for example, we have toxic chemicals. Toxic chemicals were overstated or could have been understated because of standardizations, measurements that were not up to the standard. And the impact of this was in the reports that were being seen internally as well as by the public. It also affects the policies that are being made for the public as well as the enforcement actions that organizations that are taken on organizations that will violate the Clean Water Act. So therefore, ECA decided that the IT department wanted the IT department to come up with some sort of a technology solution that was considered better for planning, enforcement, as well as for reporting purposes. Next slide. So now let's look at the current process. The current process on the left, you will see that the data scientist or the data staff, they schedule a survey via email. This is a manual process. There is a back and forth communication between the agency staff and the scientist to schedule a date. Once the date is set, the staff go and visit a site like a reservoir, and they do some tests, collect some samples, put this data on paper, and mail it to the main office. At the main office, you will find that the agency staff, they enter the data into the system, they validate the data manually, and then put it in a series of access databases or spreadsheets. So that is why you will find that the reporting issue would be a problem. You have to access the reports from the various data elements which are present in different databases. And if this validation process is failed, the manual one, it is sent back to the agency staff who has to revisit the site all over again. In addition, you will find that they have partner agencies, which are agencies which do independent tests, and they also collect data and enter this data via a flat file into the system. All of this does not does not have any data standards. So each of the partners comes up with its own data files. Next slide. So now let's look at why does it take so long? Why is the time to analysis so slow? There are several different reasons. Scheduling. We saw that that was a manual process and that would take a long time. There was extensive communication via email between the staff, and that took approximately a week. Then we have the data collection process. This is where the data is being collected on paper forms. And this is labor intensive, filling out the forms, and also has a potential for errors. The survey also could get lost or dropped in the water. Then once the data, all this data is being collected, it is being entered into a series of access databases as well as spreadsheets. And that means each one of them has data elements which are different. So the data management practices are also now pretty laborious and takes a lot of time. The manual validation at this point is still, takes a lot of time, and extracting the data or creating reports is also labor intensive. Lack of standardization is causing all this problem of taking 6 weeks for the reports to come. So now let's see how we can address this problem. Scheduling. By creating digitized schedules, we can do automatic notification features that will speeden this part of the schedule. We can have data collections, that is converting the paper for surveys to digital forms, automating the validation process, and standardizing these data elements in the way data is being collected. And we can, once this data is collected, we can consolidate all the spreadsheets. We can consolidate the access databases into a centralized and common data repository. In that way, all the data which is being migrated within as well as from the partner agencies, they will follow a new data element standard. The data management practices that we see, we would like to have a centralized data management tool which will do an automatic validation checks for every data exchange which takes place. We can also implement role-based access controls, that is to maintain data integrity even though this data is considered public. We also have the partner agencies which would use this standard data format to exchange data, so different partners will not be using different formats anymore. And with that, I will hand it over to Denise.
Thank you, Joe. To address the issues with time to analysis, we are proposing the development of the SAW platform. The SAW platform is an information management platform named after the monitoring program's soil, air, and water units. First, let's take a look at the 5 components that make up the platform. The first component of the SAW platform is the SAW portal. The portal is a web-based application that agency staff will use to request new surveys, review and manage their survey results, and analyze the collected data. Next, we have GoCanvas, a cloud-based form automation tool integrated with the SAW portal. Using GoCanvas, we will convert the current set of paper surveys to digital surveys. These digital surveys will be used by field staff to enter data into the system while conducting an on-site visit. Additionally, GoCanvas will also serve as a dispatch and scheduling service for requested surveys. The next component is the QA repository. This repository is a data staging area used to process incoming data from the field and our external partners. As the data flows into the system, it goes through an automated validation service that flags any abnormal data. For example, if an average volume reading on a test result is 1 milliliter and the data comes in with 500 milliliter entry, the system will flag the results for review by staff. The fourth component of the SAW platform is the SAW API. The API is a collection of web services based on the REST architecture style that will provide a way for the agency to exchange data with their partners, while at the same time providing the public access to the collected data. The last component is the central repository. This is a SQL database that will consolidate the current collection of Excel and Access databases into a single data repository, making it easier for agency staff to analyze and review the data. Now we will review how the data will be collected and analyzed using the new platform. The internal data collection process will start with step 1. This is the creation of a survey request in the SAW portal. This request will be created by the agency staff and contain the survey type and details needed by the field staff to complete the survey. This request is then sent over to GoCanvas for dispatch to field staff, who will then schedule the on-site visit using GoCanvas's scheduling application. Once the visit is scheduled, the survey request status is updated in the SAW portal for agency staff to review. Once the field staff are on site, they will complete the survey using GoCanvas's mobile application and upload their survey results via the network when they get back to the remote office. Once the data has been uploaded to GoCanvas, the SAW portal will pull the data into the QA repository. As the data arrives in the QA repository, it will flow through the automated data validation services with any abnormal results flagged for review. Once this process is completed, an email is sent to the survey requester notifying them that the survey request has been received. The requester will then review the results and have the option of either fixing any issues and approving the results for long-term storage, or they can reject the results and request another survey. Once the survey results are uploaded to the central repository, the data is accessible to the agency staff via the SAW portal. From the analysis dashboard, they can create and share custom reports from the data collected. Our external partners will now use the SAW API to share information with the agency. They will upload their survey results to the QA repository, and like our internal data collection, all results will flow through the validation and approval processes before being sent to the central repository. Now that you have seen the process, we will review some mock-ups depicting what the SAW portal and GoCanvas will look like. First, we have the survey request. The survey request will contain the site information, survey details, and even allow staff to select the equipment needed for the visit. Now let's take a look at the scheduling process in GoCanvas. This is a screenshot of GoCanvas's group scheduling application that the field staff will use to self-schedule their on-site visits. Let's take a look at the digital survey in GoCanvas's mobile app. The surveys created with GoCanvas will pre-populate the site information and provide reference data from the database for field staff to quickly and easily complete the survey results while on site. Let's take a look at our survey dashboard. Agency staff will use the dashboard to create and track the status of the survey request. Additionally, once the data is uploaded, they will also use the dashboard to review and approve their survey results. Now let's take a look at the mock-up of a custom report in the analysis dashboard. The custom reporting allows staff to build reports for review, share those with others, and/or download for further analysis. Now that you've seen what the SAW platform looks like and how it works, let's review the benefits. The portal survey and analysis dashboard offers a central access point for managing surveys and interacting with the monitoring data. The survey dashboard simplifies the management of surveys by eliminating the back and forth emails associated with the current process. Additionally, the analysis dashboard eliminates the cumbersome and laborious process of building reports and extracts associated with the disparate collection of storage solutions in the current environment. The conversion to digital surveys significantly reduces the time to analysis by eliminating the inherent time delays with mailing of paper surveys. Results now arrive in the main office in a matter of hours versus the weeks associated with the current process. Additionally, by having the field staff enter the results directly into the system's digital surveys, it eliminates the risk of misinterpretation of handwritten results during the data entry process, improving the overall accuracy of the data collected. To further ensure data quality and eliminate manual processes, we have introduced the QA repository, where the automated validation services apply consistent validation rules to the data and reduce the time to analysis, as validation now occurs in a matter of seconds versus the traditional 2 weeks seen in the current process. Lastly, the SAW API provides an easier data exchange process with our agency partners, making it easier to exchange new data, while at the same time standardizing the way we receive the data elements, improving the quality of the data received. Next up is Matt, who will go over the SAW platform's architecture and implementation plans.
Thank you, Denise. As you have seen, SAW is a multi-component solution that has quite a few moving parts. In the next slide, we will be covering how these components fit into the bigger picture of how and where the data is flowing. Shown in the following diagram are the pieces that make up our overall SAW platform. The SAW platform will be hosted in the state's private cloud, with the exception of GoCanvas, which is being hosted outside of the organization. You can see the interactions and flow of data for agency and field staff, authentication for agency and field staff through ECA's Active Directory, partner data exchange using the SAW API, and the external GoCanvas integration, with all information ultimately residing in the centralized database. Lastly, I wanted to mention all communications between systems, both internally and externally, will be encrypted. Since we have covered what SAW is, how it works, and some of its internal components, I'll now be going over our implementation plan and the timeline by which we will be developing and rolling out the SAW platform. Noting the development items required for the custom SAW platform, as well as the need for existing data migration, we created a meaningful rollout plan by which the pieces of our SAW platform will be implemented. In the next slide, we'll be going over our project timeline and how our phased rollout plan is going to work. Shown here is our overall timeline for the SAW platform development and rollout. The implementation will be conducted over 3 years. It will include 3 months for planning, analysis, and design, 6 months for SAW development. There will also be a 3-month pilot, which will include the dual entry of programs data in a test environment with the SAW platform to correlate and compare the results, ensuring the migration process is accurate and meets requirements. This feedback will be used to prepare the program's data for the production release. Lastly, there will be a 2-year window for the phased rollout of the platform on a per program basis. In the next slide, I will go into a little more detail about what the phased rollout will entail. The phased rollout will be part of an overall development lifecycle with a continuous feedback loop for program improvement, starting with the air program and ending with the water program. This phased rollout plan is necessary as data is currently being housed on multiple disparate databases. Once the data has been migrated to the new solution, the old systems and disparate databases will be shut down. This means that once data migration has completed for a program, it will be impossible to roll the data back. Once one program is rolled out and deficiencies are identified, they will be corrected and a new process applied to the rollout of the next program. After discussing the implementation timeline, I will now turn the presentation over to Vahid to go over our final project costs.
Well, thank you, Matt. We're expecting a 5-year project cost to be approximately slightly over $2.1 million. We categorize the cost into fixed project costs that will carry us through the first 3 years for an amount of $1.6 million. And the recurring project cost that covers us from the year 1 all the way up to the 5th year at $94,000 a year. The fixed cost of the project involves the initial development of the SAW implementation, etc., the one time, and the recurring cost is focused towards GoCanvas subscription service and the state's provided private cloud services that we intend to use. The team has put together a comprehensive solution to address agencies' requests to introduce and reduce the current time to analysis by eliminating the manual processes by introducing the SAW platform. We have decreased the total time to analysis of survey data coming in by 95%. We intend to improve the accuracy and integrity of the data by computerizing the survey data collected and establishing a single source of ECA data for everyone within the programs. In addition, we have created consistency across all the data elements. And lastly, The automated validation, enhanced scheduling, and overall standardization implementation that we have put through will increase the productivity within all of your teams and programs. And thank you for your attention, and we're happy to answer any questions at this time.
Okay, let me turn it over to the committee. Let me just pop.
Department. Thanks, DJ. Hello, College Admissions Department. We are Schoolship, and we design affordable software with college admissions officers' needs in mind. We sat down to discuss with a handful of you to gain insight on what goes on during a typical round of admissions cycles. Say, do you feel that you get too many student applications each year and you never have enough time to review them all? Are you tired of manually entering in data for applicants so that you can review? Do you wish there was a better way to manage your applications? What if we can show you how to improve on this by utilizing an improved and affordable software platform that can help you streamline the process of reviewing candidates? Today, we want to present to you the software solution that will address these concerns. As a startup, our first struggle was to secure proper funding. Fortunately, we received a generous investment of $5 million from William Philip Cunningham III, and our mission to start Schoolship began. While we are a small team, we each have a capacity to fill in the roles outside of our expertise, wearing many hats. The roles and responsibilities of each participant in the Schoolship team are integral to the successful implementation of our platform. Come meet the team that will help you streamline the college admissions process.
Hi everyone, I'm Phil Cunningham and I am the Innovation Sherpa at Schoolship.
Hey guys, I'm Matt Damaris. I'm the Digital Overlord.
Hey everyone, I'm Christine Liu and I'm the Chief Storyteller.
Hi, I'm Liu Liu and I'm the Technical Ninja.
And my name is Jane Ye. My role is the Unicorn Growth Hacker. Now Matt will take us through our business challenge.
Thank you, Jane. So from our research and interviews with various admissions officers, we identified 3 primary business challenges. First off, application growth. The number of college applicants is increasing each year with a projected increase of 15% over the next 5 years. So there is a need to be able to accommodate this trend without expanding your workforce. The next challenge you identified was manual processes. You want to lessen the need for manual intervention, such as transferring data from one system to another or verifying student-reported test scores and high school curriculums. Currently, you're using a combination of software tools such as Salesforce, Slate, and TargetX, but those all require various levels of manual data entry. So your feedback really indicated to us that you would prefer not to have to swivel between multiple platforms. And lastly, the third concern uncovered during our interviews was around recruiting. We found that admissions officers like yourselves want automated analytics to help with the recruiting strategies instead of having to manually aggregate data from multiple sources and then create your own spreadsheets just to satisfy reporting needs. So with that, I'll pass it over to Phil, who will review our financial validation of our business problem.
Thanks, Matt. So we did a quick industry study just to validate our business case and highlight the need for software. So in that study, we found that 84,000 applications per year were being processed by schools on average, and it takes about 15 minutes per application to complete. So this translates into 21,000 work hours each school has to invest. And if they're paying about $30 to $70 per admissions officer, this translates into $600,000 to about $1.5 million that are spent by that school for that admission cycle. So now I'd pass it off to Jane to talk a little bit about the business objectives.
Thanks, Phil. So with our business problems defined and financially validated, we derived our primary business objectives to match the business concerns. These include application efficiencies. This aids universities by providing end-to-end application process management. And we also reduce manual application processing time through automation, thereby providing application workflow and fallout. We also manage workflow logistics, which promises a reduction in handoffs between stages. Finally, for recruiting strategies, we target the students that are most likely to enroll by building and utilizing a data analytics engine during off-peak season. In short, the neat thing about our company is that we focus on developing software that is purposely built to support the college admissions application process. With that, moving along, Christine will walk us through the business workflow.
So after proving that we have a valid business case and defining our business objectives, we followed up with all of you to figure out your current admissions lifecycle processes in order to identify common pain points and what you would like to see as a proposed process. And this is the image that we came up with. So the left side illustrates the current process. So in the current process, there are 8 common steps that are manually performed by all the admissions officers in your department, as indicated by the person icon. So for example, you must manually create the student profile and another application that's dedicated for admissions usage, such as Salesforce, Slate, or PeopleSoft. You must manually verify the student submitted standardized testing scores against the scores reported by a testing agency, such as College Board. You must manually evaluate the student's high school in order to determine if the candidate made the most of their academic high school career or not. You must manually track down and assess teacher recommendation letters and manually analyze the student's personnel essay. So there's so many different components to a completed application that come from many different sources, such as the student, the testing agency, or even the high school, that portions can often be delayed or lost between handoffs. And this is not really discovered until you or another person in your department is ready to review that application. So then these applications will require further re-review and reinvestment of time in order to make sure it's complete before it even gets reviewed. And so the last part of the current admissions lifecycle is to manually create reports using Excel or VBA that can help with recruiting next year. And so now we move to the proposed process on the right. So in addition to identifying the common pain points and helping us outline the current processes, the admissions officers we interviewed and you all provided process improvements that you guys would want to see in a school ship solution. And it would help us lower the manual handoff rate from 8 touches to 3 by identifying areas that can be potentially automated, which is represented by the rocket ship. So overall, you and other admissions officers want to see changes in admissions processes to have all the tedious manual tasks automated. You want access to case management functionality that provide automated application workflow and also fallout management. And you also want data-driven recruitment strategies so that you can focus your efforts on accommodating more applications and reviewing the candidates more thoroughly. So now I'm going to pass it to Lou, who will describe the solution based on the process changes you suggested.
Thank you. So as Christine mentioned above, from this continuous conversations we had with you guys and your fellow admission officers, we want to present to you a software platform solution that is better than Slate, Salesforce, any of the competitors that you have identified. So to answer your needs, here are the 5 features we thought that would offer the most benefit to you on your job, with the intention to roll them out in phases. So note that the features intended for the first version has a 1 next to the bubble, and the features intended for version 2 release have a number 2 next to them. So now I'm going to cover the features for the first version. So the first feature is an automated application feed. This allows ingestion from data from various sources like Common App, high school websites, and College Board. This automatic ingestion removes large portions of manual processing that was a major pain point mentioned across admission offices. Next, case management. This feature detects missing data from the applications, and it automatically contacts the responsible party for that missing information. And it also allows customization of rules and alerts when needed to suit that admissions needs. Next is data analytics feature. This aggregates data from past admission cycles, so it's readily available for easy candidate comparison. Several admission offices ask for the ability to utilize a product during non-peak admission cycles to develop future recruiting strategies, and this feature fulfills that need. So the next 2 features are intended for version 2 of the release. The first one of those 2 is internal communications. This allows messaging capability on the platform for in-time and in-context information exchange and relevant metadata to track when that information was sent and format of that information. The next and the last one is a social media scraper. This allows connection to sources like LinkedIn to pull in work experience information. This functionality is completely optional and is opted in by recent graduates and alums. We regularly review our privacy regulations to ensure that we're up to date with our data protection practices. and recent grads and alums can opt out at any point, at which time we'll respect their wish and delete their information from our databases. So the purpose of this feature is to provide insight into recent grads, give us a more accurate portrayal of their career trajectories, and use to connect working alums with current students looking for internships and job opportunities. So at this point, I'll pass on to Phil for application architecture.
Thanks, Lou. So I'll expand on our application architecture a little bit. First off, I'd like to point out we're leveraging Kubernetes here to adopt the microservice-based architecture. So what you see in the picture on the right is a customer Kubernetes cluster, and we layered this. So starting at the bottom, we have our data sources. Within the cluster, we have our common services microservices, and then we also have our application microservices at the very top. So I'll just walk through starting at the bottom. Here you'll see the data sources that you guys may already be using, things like College Board, Common App, schools, any existing databases or databases within a high school. And what we're doing is we're pulling that into our data ingest service via REST API. And here we're leveraging Apache Kafka. So this allows us to create different pub sub topics that our other microservices can subscribe to. To the left of that, we have our UAM. And here we'll be integrating with any access management tools that you may have already existing at your school. This way you'll have a single sign-on and a seamless integration across your existing tools with this one. Going over to the right, two bubbles, we have our controller and orchestration. Again, we're integrating with Kubernetes controller here to add in some features from our continuous integration, continuous deployment pipeline. So as new microservices come out, you can set up automation to automatically deploy it. And it has your health check and auto scaling capabilities in that. And so that works in partnership with our license manager directly to the right of that. So as you're scaling up and down, the license manager is tracking licenses per deployment. And that's how our billing model is set up. So as you scale up, it'll automatically bill you for those months. As you scale down, it will remove those different services from your monthly bill. And then on the far right there, we have our monitoring, logging, and application performance metrics. So here we're doing things like security monitoring, application performance monitoring. We can look at different latencies across REST APIs and microservices. So if you need fine tuning for platform performance, we can accommodate that for you. Moving up to application microservices, student application profile, as Lou mentioned, does a lot of automation around data. One thing I'll point out there is this is happening asynchronously. So you don't have to wait for like essays to come in if you only want to look at, college or SAT scores. To the right, we have case management. So Peter, you might be interested in this. If you're looking for closed loop automation, this is where you're going to do all of your policy management. So if you want to set up things like automatically identify the SMEs within your organization, you can set it to reroute cases to those specific SMEs. And then to the right of that, we have our data analytics. Here we're leveraging Elasticstack once again. This part we're using the Kibana dashboard to create those different data visualization and data analytics that you might be interested in. Finally, the last two bubbles, social media scraper and communications engine, we're planning that for phase 2, so we'll have more information about that in the future. So next, I'd like to pass it off to Matt to talk a little bit about an example use case.
Great, thanks, Phil. So here we have an example of a scenario that many admissions officers face. In this case, the applicant, John Snow, has completed all of his application requirements, except his profile is missing one thing, the recommendation letter. It's highlighted here in orange. Using a case management microservice, our software will identify that the recommendation letter is missing and will send an alert to the admissions officers. SchoolShip's student app profile page will provide more granular detail on this missing requirement and will also allow users to follow up. I will now pass it over to Christine, who will walk us through the user interface.
Thanks, Matt. So now we're going to go through a user interface demo that showcases how the features, the architecture, and use cases come together. Okay, so this is the login screen of our application. So for admissions officers, if you integrated SchoolShip with your existing single sign-on or have a username or password, you can simply type it in and press login. Then SchoolShip will bring you to a dashboard with current application status. So there's a countdown here that shows you how much time you have left to make admissions decisions. There's an alert widget here that shows you what type of email alerts you currently have set. For example, you can set alert notifications when an application is ready for admissions review, or automated emails to high schools or students if portions of the application have not been received yet. And down here, there's a location map that shows you what high schools your applicants are coming from for the given application cycle. So if we go to the top and we click on Student App Profile, you're brought to a table of all the applicants with their acceptance and review status. So this table is both sortable and filterable. So if you search for a keyword like need review, the count in the table would change accordingly. And you can also add more columns here if you want to. And so let's click on one of the candidates. Let's say, for example, that Matt used in his use case, John Snow. This is a candidate that needs to be reviewed but has overdue items. So if we click on this candidate, we would get a candidate profile for that applicant. So at the top here, you have the candidate name, John Snow, the ability to accept, reject, or waitlist or defer this candidate, the high-level status, which you saw on the previous table, and a legend here that defines the status values of the workflow tasks. And down here on the left, you have all the workflow tasks. And these workflow tasks are steps that the admissions officers can complete before making a decision on a candidate. And the ones that we choose to list here are the most common workflow tasks among all the colleges per our interviews. And so the green check mark here represents parts of the applications that are ready for review. And so in the student profile in the center here, Schoolship pulls all the relevant data from the Common App in regards to the student profile. And on the right here is the internal communications that your admissions team can talk about the candidate at hand or leave notes for each other. And so if you want to confirm that you reviewed the student profile application portion, you simply press reviewed, and the check mark will turn from green to blue to indicate complete. And so for the standardized test scores, you can see that the candidate's self-reported score on the Common App on the left, and the scores reported by College Board, a testing agency, on the right. So Schoolship did the verification, and what the student reported matches what the testing agency has. So if you're okay with this completely, you can press reviewed, and the green check mark would turn blue to indicate complete. And so the same concept for the high school panel workflow tasks. And so if you're not ready to mark this as complete, you can simply press on a different panel. So clicking on essay will bring you to the student essay. So we have the main source of data for the student essay coming from Common App, but we also have other helpful tools in place, such as a plagiarism checker. So that helps to see if this essay was submitted previously or in a previous year. And so here was our problem, clicking on the recommendation letters. From this page, it's easy to see that Recommender 2 has not submitted this candidate's recommendation letter yet, and that 3 automated alerts have went out to this Recommender 2. So at this point, the admissions officer can pursue further action and open a case for this application. And so the other 2 steps are the review board and recruitment. So depending on the strength of the candidate, or if this is a borderline candidate, you can set up a review board with your team and to discuss this candidate further. And lastly, the recruitment option is to see the candidate interests. How interested is this candidate in your school? Did they go to a campus tour? Or how interested are you in this candidate? If you want to accept them, is this someone you want to let them know early by giving them a likely letter? Or is this someone that you would potentially want to give a scholarship opportunity to? And so this concludes the student app application profile portion of the demo. And now I'll return back to the slides. So now I'll pass it to Phil to go over timeline.
Thanks, Christine. So when will our product be ready? Right now, we're targeting a beta launch in August 2020. So we'll be up and running for the September 2020 to January 2021 application season. And we'll be using an agile approach with iterations of about 2 weeks. So that means within those 2 weeks, we'll have cycles for design, requirements, development, testing, feedback, and deployment. And we'd like to invite admissions officers to have an opportunity to be involved and provide feedback during the design suggestion and the development cycle, depending on how much involvement they want to have. So next, I'll pass it over to Lou to talk a little bit about pricing and support.
Thank you. So the customer's invoice will consist of 2 portions, the pricing and the support costs. All the numbers shown here are on a monthly basis. So on top, We have a pay for what you need pricing structure since we recognize that all schools needs may vary from one admission cycle to next. So we do allow that flexibility for resources to be changed as needed. So on the top here, we have the software pricing formula, which consists of 3 parts. The first is a flat fee that schools pay for, which is a common microservice platform license. Next is the infrastructure cost, which is derived from AWS, which is our cloud provider of choice. Next is a core application microservice, which is priced at $750 per microservice. An example of that would be the data analytics microservice we mentioned before. On the bottom is a table for our support structure. Support pricing is tiered per month, and you can select the one most suitable for your school's needs, with increasingly more customization and support resources as you go from left to right. So our bare necessities is our standard tier. Next is our no troubles, which is our plus tier, and our premium tier is Hakuna Matata. The intention for that is you'll have no more technical worries for the rest of your days. At this point, I'll open up the floor for questions. And for any that we don't have time to get to today, please feel free to email us at info@schoolship.xyz. Thank you.
Okay, thank you. Let's pause the recording. All right, there we go. Yes, Takayuki cut your joking reference there, so that's good. Okay, last team. Oh, wow. Clippy, are you guys ready to go?
Yes.
Yep.
Okay, recording has started. You guys now have the floor. This is another startup. These guys have a very interesting solution, and they are basically, think of yourselves as the people on Shark Tank. You were venture capitalists that they're talking to because they're looking for some funding. So they really are after money. Okay, Clippy, go for it.
All right. Hello and welcome. So today we are here to ask for $1.5 million investment in seed round for our product Clippy 2.0. And we believe that we can present you a really strong business case for that. So basically, what is Clippy 2.0? Clippy 2.0 is a software-based content management and governance solution. And you can think of it as like a add-in into common storage systems such as Dropbox or Google Share that are typically used by smaller companies. And we believe this product has great market potential, not only because it addresses exactly our customer needs, but it's also in a really attractive market that is supposed to more than double of it in the next years, and there's no large established competitor yet. Really strong technology, like effective backend, really easy to use front end, and proven effectiveness. So we could really validate that there's a large monetary benefit for our customers in implementing this. So we're really excited to bring this to you today. Let's maybe start with what initially inspired us to invent something like Clippy 2.0. So our mission was to really provide our customers with best-in-class content management and governance solution that we firmly believe does not exist in the market today. This meant inventing something which is both affordable for smaller companies, easy to use and employ, meaning it also integrates with the storage systems our clients use, and really targets exactly what our customers want and need. And the more longer term vision behind that is to really become the go-to partner for our customers in everything that has to do with content creation, storage, and management. So let's get to our customers' main problems yet. So we found that our customers, in terms of content management and governance, are struggling with 3 main pain points. The first one is content chaos, and I'm pretty sure you're familiar with that. So basically, in most smaller companies, no real standardized rules exist on how to save, where to store, how to version files. And one complicating factor there is that our customers use an average of 4 to 5 different storage systems. So data literally lands everywhere. And this leads, we found, to employees spending 20% of their time every day looking for information. That's 1 out of 5 employees. More than 10% of files being misfiled or lost, costing several $100s per file. And there's also huge cost of versioning errors. So just this pain point in itself, there's already huge potential in reducing that. The second point is about the difficulty to manage access control. Again, there's a complicating factor if you have several storage systems. And this leads today to 7 out of employees having access to at least one data set that you're not supposed to see. And this is quite risky because if these data leaks are exploited or detected, data breaches are really expensive and cost an average of $8 million. The final point is about the lack of transparency in monitoring abilities. And that basically our clients told us that they see this as the biggest gap in the market space today, that they can't really see their content management and governance processes across all their storage systems, leading them to having no insights, which is quite a big missed out opportunity on also improving their processes. So one can think that this problem elevates the other two problems. So I already mentioned some numbers, but taking these three problems together, the cost for smaller companies are $900,000 per year, which is obviously enormous, but we firmly believe that Clippy manages to mitigate these problems and these costs significantly. So next, my colleague Casey is going to tell you how it does so.
Thank you, Enza. So our solution, Clippy 2.0, addresses each of these pain points specifically. It masters the content chaos by classifying and categorizing files based on company policy, which saves people time. And for example, if an employee isn't sure whether a certain department uses Google Drive or Dropbox, they would have to get in touch with that department, wait for a response, and get the information they need. But with Clippy, they can just search through the Clippy system, and Clippy will be able to tell them where those files are stored that they need. It handles access control management by scanning the contents of files and suggesting document placement and access permissions in real time. So this saves employees time and prevents the accidental revealing of potentially sensitive documents. So for example, if a new employee is in and is handling a sensitive document with some company secrets, say, Clippy will scan through this document, and as the new employee is about to save it to an insecure location, Clippy will hop in and say, hey, it looks like this file is about to go in a place that it shouldn't. Maybe we should put it over here. At which point the user will be able to say, oh, thank you, Clippy, that's exactly where I want to put it. Or no, actually, Clippy, it should go here. And then Clippy will learn from that. And it also establishes transparency and monitoring. It integrates with all storage platforms, with the Google Drives, the Dropboxes, the SharePoints, and provides a real-time single pane of glass dashboard so you can see where all the files are. And another thing that Clippy 2.0 does is provide executive management with high-level reports of its data storage posture in order to make document management decisions. So for example, it will give a dashboard of the success rate of Clippy 2.0's file placement and permission suggestions. How many times a user said, oh, great, thanks, Clippy, that's exactly where I wanted to put that, and how many times Clippy had to be corrected. And we are offering this service at $300 a month per company, flat pricing. If we take a look at the market on the next slide, it's a great time to hop in. From 2019 to 2024, the market is expected to more than double to almost $5 billion. And for solutions for small and medium enterprises, against our direct competitors, this market is supposed to grow even more than that. It's supposed to have a 35% growth rate, so it's a great time to jump in. And speaking of the features of Clippy 2.0, and taking all of this into account, there's no real major prohibitive player in this market yet. And there are a lot of players that do some of what Clippy does, but there is nothing on the market right now that does all that Clippy does. So looking at these different players and looking at our competitive pricing, we've got a great product here that we are ready to bring to market and succeed. And to talk about the tech stuff, I'm going to send it over to Scott Willett. Scott?
Thanks, Casey. So I'm here to kind of demystify some of the claims about what we've said our system can do. I'm going to give you some context about what a Clippy 2.0 deployment looks like and a high-level architecture overview. We have a more detailed diagram in our backup slides if you're so interested. Please save those questions for later. And lastly, we'll walk through an example user journey through our front end to better illustrate our system's overall utility. To give you some context, as you now know, Clippy 2.0 is a powerful tool to help wrangle a given company's document chaos, particularly when multiple document storage systems are involved. We have three main components that provide utility and help guide users towards success in this effort. We have webhook integrations with each of these document storage systems. that allow us to gather information when certain actions occur, such as new documents being created or edited. We have our backend that ingests these webhook payloads, acts upon them to provide meaningful remediation suggestions for our users, and it also aggregates metrics, just like Casey mentioned, for our front end to consume. And our front end is here to provide a means for users to better manage and learn from this aforementioned chaos. So now we'll take a little peek at an architecture overview. I wanted to point out first that the utility of our system really depends on some system configuration out of the gate. And my colleague Casey kind of alluded to this when he mentioned company policy earlier. So to be able to successfully capture information from these disparate document storage systems and to be able to act upon scenarios of a given company's choosing, we expose easy to interact with UIs and APIs that allow Clippy 2.0 administrators to configure these webhook integrations that I mentioned, different keywords, topics, and phrases of interest to a company that are desired to be detected within these documents by the managed natural language processing offering that we use, as well as the setup of rules. So for example, what should be done if an event of type X is detected? So this tooling gives Clippy 2.0 administrators a highly configurable self-service solution for managing and maintaining their deployments. So now back to the diagram, let's see how data kind of flows through our system. On our left, we have the document storage systems that you've heard mentioned. Dropbox, Google Drive, SharePoint are a few that we support at this moment. These systems are all configured now from a Clippy 2.0 administrator to integrate with webhook events. So different actions taken in these systems fire off webhook publishes, and this is our avenue for acquiring document contents and chain sets in our backend. So each of these actions in these systems generates one of these publishes, like I mentioned, and these events generally contain a small amount of metadata about a document, and we leverage unique document identifiers within this metadata to then reach out to these services to gather full document contents. This type of integration, I wanted to make note, also has the potential to generate lots of traffic. Just think about hundreds of users making hundreds of edits to hundreds of documents daily. Luckily, our system leverages some elastic AWS managed offerings that are designed with scalability in mind. Also notably, the traffic patterns are kind of predictable, so we're able to auto provision additional resources based on a given company's work patterns when employees are in work. In the middle of our diagram, we see our backend. We want to make it clear that our backend is only acting as an intermediary in regards to the contents of these documents. We're never persisting these document contents. They only reside within our application container's memory as we act upon them. We're just acting as a pass-through to different services, namely AWS Comprehend, which is the managed natural language processing service that we interact with. Currently, we provide two main ways that we gain insights from this document data. The first way is that we compute and persist hashes or fingerprints of these documents. Given that these identifiers uniquely mark a document, we're able to safely identify the same documents cropping up in other disparate storage systems, enabling us to identify costly versioning errors. So if document A with fingerprint X crops up in Dropbox, and we see that same fingerprint in SharePoint, we're able to act upon that given a company's set of rules they've configured. Lastly, we aggregate metrics in our backend for each of these suggestions and whether or not they're accepted by our users, so that we're able to provide our front end with some meaningful data about the utility of our system. And on the right, we see our front end boundary. Here is where users can view and approve these remediation suggestions from our backend. And then Clippy will automate the rest given a yes answer. So now we'll walk through a typical user journey to kind of pull all these puzzle pieces together and see better the utility that our system provides. So here on the left, we see Sarah. She's a sales manager of one of the companies we're targeting. She's looking at an overview of documents in the Clippy 2.0 system that she has access to. As we can see, there's an indication of the document sources, names, and the number of remediation actions to be taken. She happens to see that q1report.docx has the most actions to be taken, so she clicks through to see the detailed view for that given document. Now in this detail view, we see a similar indicator for our Q1 report, along with a link through to the live document for a user's convenience. We also see a listing of actions to be taken with an indication of the severity of each action, along with the colored warning symbols to their left. As Sarah hovers over each of these actions in our system, she sees a preview of the pros that triggered said action, if applicable. She looks at the second listing here and sees that based on the rules set up by her company's Clippy administrator, Karsten, her document has been detected as being miscategorized, and she clicks through to accept the fix. Here we see Clippy 2.0 prompting Sarah for approval, and our system will automate the movement of this document to the quarterly reports directory in her company's Dropbox, given her yes answer. We also see our friendly Clippy 2.0 administrator, Karsten, here on the right from before, who is able to act upon these suggestions and fixes that may have become stale or forgotten. So he has more permissive access to the system. Someone like Karsten is also able to view our single pane of glass UI, where we have dashboards that display the aggregated metrics from our backend. So this is the spot where Karsten would leverage Clippy to generate the executive level reports that Casey alluded to before. We also wanted to note here that Clippy is not only providing utility by highlighting and automating these suggested actions, but is providing indirect benefit through this type of holistic view. For example, if Karsten notices here that there has been an increasing number of document versioning errors in the past month, he can then talk to upper management to spearhead a training session for the involved employees to help reduce this issue moving forward. This is just a single example of many ways our platform can enable its users to make educated decisions based off of quantitative data. Now I'll hand it off to Scott J. to talk about our success factor and future plans.
Awesome, thank you, Scott. So at this point, you've heard a bit about the need for a document management solution for small to medium startups, and you've seen how our solution meets those needs. And now I'm going to tell you what makes our solution stand apart. So the Clippy 2.0 team understands that like any technology, it's only going to be as successful in the long run as the number of employees that adopt the tool. If employees aren't adopting it, there's no way for Clippy 2.0 to provide remediation suggestions and identify these documents. So to that end, the Clippy 2.0 team provides a implementation toolkit. This combines some of the best practices in project and change management, but
Did we lose Scott? Yeah, I think so.
All right. Okay, then we can present this.
Yeah, you guys want to pick
Wait.
up? Oh, Scott, are you back?
Scott, are you back?
Okay. We were about to take over.
You vanished for like the last 30 seconds or so.
I'm here. Wait, am I here?
You
okay, can hear you now. Yeah,
you're back now.
Oh, okay. Sorry. Yeah, I'm ready for the next slide. Sorry. I'm going to tell you a little bit about this customer success enablement through a customer success story with Psychromoft. So Psychromoft is a small to medium-sized startup here in Boston. They're your typical software startup with many document management solutions in place, your Slack, Dropbox, SharePoint. There's even the marketing team that's using their own solution that nobody knows about. And this really led to problems for Psychromoft because there was a document that was shared on a company Slack channel. It got in the wrong hands of a competitor. That competitor beat them to market on a product they were working on. And that resulted in a $1 million revenue loss and 10% customer loss in 2018. On top of that, there was untold damage to their reputation as a company that's not good to work for, really hard to work efficiently with all these different document management solutions in place. So through our implementation of Clippy, we spent 2 weeks with the company helping them calibrate the software, help it understand what keywords to look for, which documents are potentially sensitive. And I think of all the results on this page, the most compelling is that Clippy was able to identify 20 instances where an employee was about to save a document in a location that they shouldn't have. And you know, we have potentially avoided another $1 million hit that they had a couple years ago. So now I want to tell you about where we are and where we're headed as a company. So we've completed our two most important milestones. So we have a minimum viable product, and it's been tested and iterated with our pilot customer, Sycromoft, which has validated and quantified its effectiveness. So now we're ready to launch. And so far, all of our expenses have been 100% self-financed. And this is what we're seeking today. $1.5 million in seed funding, which will be used to gain traction by building and training a sales team to acquire new customers. Next slide, please, Scott. So our 5-year goal is to achieve a 10% market share of our direct competitors who are providing document management solutions for things like Google Drive, Dropbox, SharePoint, et cetera. And under those assumptions for market growth that Casey talked about earlier, this would be approximately $35 million in sales. And the seed funding we get now is it really sets the stage for our company to gain traction with new customers and really achieve that 10% market share goal. So this is a big moment for the company. And with that, I want to leave you with these 3 takeaways that you should know about us. We're addressing a growing and underserved market. Clippy 2.0 is proven to bring major benefits to its customers, and we're ready to gain traction. So you've seen the need, and we'd love for you all to join us by partnering with us. And with that, we welcome any questions you have. Thank you.
Okay, thank you, Clippy team.
Excellent work.
Oh, sorry. Go ahead.
Yeah, it's clear everybody put a lot of effort into these projects and a lot of innovation, and I really enjoy seeing the innovation that comes out of these, like the farming project and the school enrollment, all of that, all of the projects really were very nice. Thank you.
Okay.
Yeah,
Thanks
very,
for the comment.
very innovative. Yeah, this course is like an incubator. Yeah, you guys are going to do great. You know, when you get out there, and thinking up all these projects.
I have to admit, when I first saw the farm one before I read it, when you said farming as a service, I thought that you might be gathering small farms that were struggling for what to do with their land, and maybe doing purpose growing relative to need.
Oh, okay.
But that was my first thought when I saw it. But great presentations. Really well done, everyone.
Okay.
Thank you, guys.
Well, congratulations, everybody. You're done. It's all over. You don't have to worry about it anymore. It's now down to the final grading, which I will try to have done, I hope, by the weekend. I'm just waiting. I'll be waiting for some feedback from the committee members, and Christina and I will do our final read-throughs, and we'll factor in the results of the presentations. And I will tell you that you all did a superb job in the presentations. Christina sends her regrets. She really wanted to be on here, but obviously her class was meeting at the same time, so she couldn't be here. They're giving their presentations right now, as a matter of fact, and they're probably still finishing up. So I want to also say that I am proud of each and every one of you. You guys did a lot of very difficult work. I know we put you through the ringer in terms of pushing you to do things in very specific ways and thinking through your problems as coherently and as concisely as you possibly could, and you guys all produced. So you can be proud of what you've done here. Outstanding. I know we've talked, and I don't know how many people have been on Canvas, but we've talked about having a little kind of party here around the time of commencement. For anybody who's interested, who wants to get on, a little Zoom party, everybody can just get on. All the pressure will be off by that point. You guys will have a chance to decompress. The grades will be in, everything will be over. So anyone who's interested in that, feel free to post something to the thread on Canvas and like what time you would be available or what day is better for you or something like that. And we'll arrive at something that works. Okay. Any final comments? Any final questions? All right. For the last time this term, we're done. Congratulations to all of you. And if you have any final questions or comments or anything like that, get back to us. Anything otherwise, yeah, you know where to find us on Canvas or whatever. And we will talk to you all soon. Have a good night. And thank you to all the committee members.
Thank you.
Thank you all.
Thank you.
Thanks.
Thank you
Bye-bye.
Thanks, everybody.
Good
DJ, I
night.
had a quick question. Where do you want us to submit our slides?
Just email them to us.
Okay, email it to you? Okay.
Yeah.
Got it.
That'd be good. Thank you. Try to get us the PDF and the PowerPoint if you have both.
Okay, got it.
Okay. Thanks.